Alright, in this next video we're going to talk about the exponential growth of the coronavirus. An appropriate topic probably for what we've been experiencing in our country and even locally. And the reason that we've moved all of our classes to this online environment, and I'm posting this video right now. I was recently informed of an article, and really there's lots of information on the internet right now, but this one particular article, The Sober Math Everyone Must Understand About the Pandemic by Jason S. Warner, was one that I think was very clear and had a lot of good information, good mathematical information on, but there are many others out there. And so some of the information that's important in trying to figure out how bad this could be, and especially in our area, deals with the doubling time of the virus, of the new cases, the actual cases versus the confirmed cases, which is interesting because that's something that's hard to figure out, and the percent of people needing hospitalization. And so the doubling time of the coronavirus, according to this article, is approximately 3 days. Now, I've also seen another article that said it was more like 6, because this was just a doubling time of the confirmed cases, but we'll go with 3 days. We can always adjust this, adjust the mathematics for other scenarios. The actual cases versus confirmed cases, that's interesting because all we ever see in the news are the confirmed cases. That's where people actually get a positive test. The problem is most people don't get tested because they aren't showing symptoms or don't even know they're sick. And even when they do get sick, there's, in our area in particular, I've seen that they're saving the tests for people who are higher risk, people who are older or have some health concerns, and so they're not even testing people that are showing symptoms because they want to save the test because they're so limited in how many there are. And so there are probably many more actual cases out there than the confirmed ones. In fact, according to this article, he quotes a Harvard, I think it was some Harvard people and some people from Massachusetts General Hospital. They say that there could be as many as 50 to 1. In other words, 50 actual cases for every confirmed case, which is pretty impressive. That I wasn't expecting it to be that high. And then the percent of people who have coronavirus and need hospitalization can be anywhere from 10 to 15%. I'm going to go with the 15% right now, but we can adjust these numbers as we go. All right. And so here's what we're going to do. We're going to start. Today is Saturday, March 21st, and as of this afternoon, there were 5 confirmed cases in our area. So Delta College serves Midland Bay and Saginaw counties. Midland had 3 confirmed cases. This was last I checked this afternoon. Bay had 1 confirmed case, and Saginaw had also 1 confirmed case, so a total of 5, right? So if you start with a total of 5 confirmed cases, that must mean then by this estimate here, 50 times that many, so that'd be 250 actual cases, 250 people actually sick in our area. Now, according to this article that I was reading, he says go with a conservative estimate of 10 to 1. So I'm going to use 10 to 1, and then you can see, I'll show you a quick way to check out 50 to 1. 10 to 1 is obviously way more conservative. So let's use a 10 to 1 ratio. So that would mean for 5 confirmed cases, there would be 50 actual cases. So let's use 50 actual cases. Okay, and now we're going to look at the doubling time. So if we have 50 actual cases, then every 3 days it doubles. Okay, so starting out day 0, we'll do a little table here. So day 0, you would have 50 cases. Day 3, this would double, and you'd have 100 cases. Day 6, that would double, and you'd have 200 cases. Day 9, this would double again, you'd have 400 cases. By day 12, you'd have 800 cases. By day 15, you would have 1,600 cases, and so forth. And so this gets very big very fast. Notice each time we move 3 days on the chart, you're multiplying by a factor of 2. That's your doubling. Okay, so doubling every time. For every 2-day jump in the chart. Okay, if you wanted to find, let's say, the number of cases after 30 days, let's say you wanted to use 30 days. Well, 30 days would be 10 doubling times. And 10 doubling times is essentially starting at 50 and multiplying by 10 twos, right? 2 times 2 times 2, that's 3, 4, 5, 6, 7, 8, 9, and 10. Now, who wants to write out 10 twos? I just did. That was weird. You can shorten that up by just saying 2 to the 10th. 50 times 2 to the 10th. It's the same thing. Well, 2 to the 10th is my favorite number, second favorite number, 1024. And so this is really 50 times 1024, which if you punch that into your calculator, you will get, what's that, 51,200. So in a 30-day period, you would end up with 51,200 people with coronavirus. That's just in the 3 counties, Bay, Midland, and Saginaw counties, okay? Okay, so that is, yeah, that's starting at 5. So now let's just say we look at, we have 15% of those people needing hospitalization, okay? So we take that number and multiply it by 15%, or 0.15, and you'll end up with 7,680 in the hospital. Okay, so that's how many would end up in the hospital. Now let's compare that. Now that seems like a lot of people. Now remember, this is just 3 counties I'm looking at. Let's compare that for a moment to the actual number of people in our 3 counties. We have Bay County. I looked this up earlier. In Bay County we have 104,000. This was as of last year, but I'll just use it. 104,239 people. In Midland we have 83,411 people, and in Saginaw there are 191,934 people, and for a total 379,584 people. So we're looking at, what's that, 1/7 roughly of the population. In 30 days, one out of every 7 people would have the coronavirus if we're going with this, with these values. Okay. Again, that is just using the 10-to-1 ratio. If I were to use, let me switch colors here. I'm going to go to the 50-to-1 ratio. If I use the 50-to-1 ratio, basically I'm going to multiply the starting number by another 5, right? Instead of 10-to-1, multiply the 10 by a 5. All that does is it multiplies the final answer by a 5, right? This 50 becomes a 250. So I would take the 7680, multiply it by 5. I'm sorry, not the 7680. It would actually be the 51,200. And that would actually be 256,000 cases. Okay. Now that is very comparable. This is actually 2/3 of the people in our 3 counties, right? 256,000 versus 379,000 is almost exactly 2/3. It's 67%. That means if we have 24 students in our class, that would be 16 out of 24 students would have it in 30 days. Literally, that's 2/3. Okay. In addition, you take that 15% now, and you end up with 38,000 people in the hospital. 38,400 in hospital. Okay, and you think, well, maybe that's not so bad. Well, let's just look at the number of hospital beds in our area. There are 4 main hospitals in our 3 counties. You have Bay Regional, you have Covenant, you have St. Mary's, and you have Mid-Michigan and Midland. And if you look at the number of hospital beds in those 4 hospitals, I looked this up this afternoon, I found 404 for Bay, 643 for Covenant, 204 for St. Mary's, and 324 for Mid-Michigan. It ends up being 1,575 hospital beds. Well, if we needed, let's go with a conservative estimate, 7,680 people in the hospital and only 1,500 hospital beds, that's literally 5 times the number of people as there are beds. So you'd have, for every 5 people who need a hospital bed, only 1 would get one. And in addition to that, the national average is that 65% of hospital beds are already used for other things, like appendicitis and heart attacks and whatever else, broken legs. And so if you took 65% of this number out, we'd then be looking at only approximately 551 beds available. Okay, so that would be the 35. So that's 35% right there. Right, 65% are used already, so 35% are still available. Okay, so you can see how this, the number of people needing the hospital is nowhere near what we have access to in our area. And if you use the less conservative 50-to-1 ratio, it's not even close. So we'd be overrun in our hospitals within 30 days. Now, yes, some people will get sick, get better, and get out. But this, hospitalizations last, weeks in some cases. Some not so bad, but it's very clear this would become a very big problem. So, for a while, I wasn't a big believer in the social distancing and the things that have taken place to get, to really put a stop to the spread of this disease. But when you look at the math, it really does seem to be, it's convincing. And so I've become pretty convinced that this may be the best option. It's kind of interesting. I'll continue with some more discussion in the next video.